welcome to the notes on 9.3. 9.3 is geometric sequences. Okay, so we've done arithmetic. So geometric sequences are when we multiply each term by a constant. So earlier we had the common difference. We were adding and subtracting the same thing to each term. Now we're going to multiply. In a geometric sequence, the ratio of any term to its preceding term is a constant value. So there's a common ratio. We're going to multiply everything by something. So for example, if we look in, there's a recursive definition for the sequence. It has two parts. There's the initial condition and then the recursive formula. Again, the formulas we don't have to worry about because we're giving you the formula sheet, so you'll be good to go there. An explicit definition for this sequence is a single formula where a of n equals a sub 1 times r to the n minus 1, so we can find exactly where it is. Okay. So is this sequence, it makes more sense when we look at it, especially since, like I said, we're going to give you the formulas. You don't need to memorize them. If we look down here, is this sequence geometric? And if so, if it is, what are A1 and R? So let's take a look. 3, 6, 12, 24, 48. We can see very simply that this is being multiplied by 2 every time. It's being doubled. So the common ratio is 2, and A sub 1 is 3. And that's as easy as we can make those. Take a look at this one. 3, 6, 9, 12, 15. We can see each time that right here, we multiply this one by 2, but then we add 3 and add 3 and add 3. This is not geometric. This is actually an arithmetic sequence. We're adding 3 each time, but it's not geometric, which is what the question is. So it's not geometric. The ratio wasn't the same each time. Take a look at this one. 3 to the 5th, 3 to the 10th, 3 to the 15th, 3 to the 20th. If we look at that, if we look at the ratio each time from this term to the one before it, and from this term to the one before it, and so on, the ratio each time is 3 to the 5th. So that one is a geometric sequence. The first term is 3 to the 5th, and the common ratio is 3 to the 5th. Pretty straightforward stuff. Let's take a second, see if you can answer 1A, B, and C. Answer those for me. All right, you're back. Let's take a look. So the answer here is, this was a yes. A1 was 2, and the ratio was 2. Okay. B was simply a no. That's arithmetic. C was a yes. A1 is 2 cubed, and the ratio here was 2 to the 4th. All right. Analyzing geometric sequences, what are the indicated terms of the geometric sequence? So what's the 10th term of this sequence? So the first term is A sub 1, which is 4. The common ratio is 12 divided by 4. So that's 3. We're telling you it's a geometric sequence, so you can just divide the next term by the previous one to find the R. Then we simply plug everything into the formula, and the 10th term of this sequence is 78,732. All right? Pretty straightforward. How do we find the second and third terms of a geometric sequence? Well, if the first term is 2 and the fourth term is negative 54, we can work backwards and solve for R. So we plug everything in that we know, we just don't know R. Finally, we solve for R and we get negative 3. So now that I know that the common ratio is negative 3, I just multiply 2 by negative 3 to get negative 6, negative 6 by negative 3 to get 18, and now I have those missing terms. Okay. Again, one of them we're working forward with the formula, the second one we're working backward with the formula, but pretty straightforward. Got it, number 2. What's the second term of that sequence? Go ahead and find that out, please. All right, you're back. The second term of that sequence could be 6, or it could be negative 6. We don't know because we don't know anything after this. If we knew the next one being positive or negative, we would know for sure. Because we don't, this can be either. If that's confusing, make sure you ask me about it in class. I'll be happy to explain it. But 3 times 2 is 6. 6 times 2 is 12. 3 times negative 2 is negative 6. And negative 6 times negative 2 is positive 12. So it could be either one. Hopefully you got that one. Let's take a look here. So how do we use a geometric sequence? Well, when a ball bounces, the heights of consecutive bounces form a geometric sequence. What are the heights of the 4th and 5th bounces? So we're telling you it's geometric. It's going from 100 to 49. We plug these in using 1 and 3 as the initial and then the third, and we solve for R, and we get 7/10 is R. Then we want to find the 4th and 5th bounce. We just plug them in respectively, find A sub 4, then A sub 5, and there are our answers. Okay. To find the height of the 10th bounce, would you use the recursive or the explicit formula and explain? And then what are the heights of the 6th and 10th bounces? Go ahead and pause the video right here and answer that. So you're back. The answer for A is we would use explicit because it's just there's only one calculation. So when we use the explicit when we're looking for one specific thing. What are the heights of the 6th and 10th? Well, the 6th is about 16.8 centimeters, and the 10th is about 0.11 centimeters. And that's just plugging those into the formula. In a geometric sequence, the square of the middle term of any three consecutive terms is equal to the product of the other two terms. So take, for example, let's look at this sequence right here. So negative 6 squared is 36. 36 is equal to this times this. Pretty neat, huh? Then if we take a look here, 18 squared is equal to 324. Well, 324 is equal to this times this. That's called the geometric mean. Okay, the geometric mean is the square root of two numbers. The square root of two numbers product. Okay, so if we wanted to know this middle number right here, we could just take 3 times 6, get 36, or 3 times 12, get 36, and the square root of 36 is 6. Okay. So using the geometric mean right here, which are the possible values for the missing term of the geometric sequence? If we take 48, you're not dismissed, sit down. 48 times 3 is 144. So this number could be 12, it could also be negative 12. We're not sure which, so the answer there is C. If the 9th and 11th terms are 45 and 80, what are the possible values for the 10th term? Go ahead and pause the video right here and give me some possible values for that 10th term. All right, you're back. Hopefully for this one you got plus or minus 60. Pretty straightforward stuff. That's it for 9-3s. Sit tight right there. We're going to do 9-5 also. Here are the 9-5 notes. 9-5 is geometric series. So just like we did arithmetic sequences in series, this is geometric sequences in series. And so the concept is very similar. What we're going to do is, just with, like it says right here, just with finite arithmetic series, we can find the sum of a finite geometric series using a formula. You'll need to know a couple things. You'll need to know the first term, the number of terms, and the common ratio. Very similar to what we did with arithmetic, just geometric. Here's the formula, which is also on the formula sheet that I gave you. So that part is sort of taken care of for you. So let's take a look right here. What is the sum of the finite geometric series from 3 to 3072? All right. So we know the first term is 3. The common ratio is 6 over 3, 12 over 6. So the common ratio is 2. The nth term is 3072. So we're going to use the explicit formula, plug everything in, and find how many terms there are. We do that in these steps right here, and we get 11. All right, so 11. Now, we can use the sum formula. We substitute everything in that we have. We have the common ratio, we have the nth term, we have how many terms. We use the nth term to find how many terms. We know the first term. We plug all that in, and the sum of that series is 6141. Okay? If we take a look right here, here it is in summation notation. So the first term is A1 equals 4 times 1/2 over 4 equals 4. So the common ratio, that's right here. That's 1/2. The lower limit is 0 and the upper limit is 20. So the number of terms is 21. Okay, that's key. We started with 0, not 1. We plug everything in. We can use a calculator on this one, and we get about 8. Okay. Go ahead and see if you can get, please, the sum of these two series. Pause the video right here and get me the sum of those two. All right, you're back. Hopefully the first one you got 315. Hopefully for the second one you got negative 1705. All right, here at the bottom, if you didn't get those, as always, we'll go over them in class. A famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on, for all 64 squares of the chessboard. The king decides that the request is a reasonable one. Now, according to the story, how many total kernels of wheat did the soldier request? Okay, so let's think about it. We identify the first term, it's 1. The common ratio is we're squaring each one, and n is 64. We write the sum formula out, we substitute in, we simplify, and we find out that the soldier was going to get 1.845 times 10 to the 19. Now, if we need to see what that looks like, 1.845, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's 3, 6, 9, 12, 15, 18, and one more for good measure. So that's, let's see, there's um, millions, billions, trillions, quadrillions. So all the soldier asked for, he made it sound really simple, but evidently the soldier paid attention in math class. The soldier was going to get 18 quadrillion kernels of wheat. That is not what the king had in mind. All right, so let's take a look down here. To save money for a vacation, you set aside $100. For each month thereafter, you plan to set aside 10% more than the previous month. How much money will you save in 12 months? So we know the starting value, it's 100. We know the common ratio here, hopefully you know that. I'm going to ask you to figure that part out. And then we know the n, how many terms, how many times. So that's 12. So go ahead and, if you can, pause the video right here and figure out how much money you'll have in 12 months. Go ahead and do that now. All right, you're back. Hopefully you got about $2,138.43. Okay. Rest of the story. So a bushel of wheat contains about 1 million kernels. The total U.S. output of wheat in a recent year was just over 2.1 billion bushels. How many years of production at that level would it take the United States to produce enough wheat to satisfy the soldiers' reasonable request? Okay, it's the rest of that story. So what we have here is the terms of a geometric sequence grow rapidly when the common ratio is greater than 1. Likewise, they diminish rapidly when the common ratio is between 0 and 1. In fact, they diminish so rapidly that an infinite geometric series has a finite sum. So, an infinite geometric series with first term a and a common ratio of less than 1 has something we can add to. If the ratio is greater than 1, it doesn't. So let's take a look at what that looks like. To say that an infinite series has a sum means that the sequence of partial sums at some point is going to get so big that n is very, very large. When an infinite series does not converge to a sum, the series diverges. An infinite geometric series with an r greater than 1 diverges. So does the series converge or diverge? Okay. If so, if it converges, what is the sum? So looking right here, since the r is less than 1, it converges. And eventually the sum here would be 2. Okay? Here, the r is greater than 1. It's negative, but it's the absolute value of it is greater than 1, so it diverges. All right, so converge, diverge. Do these converge or diverge? And if it converges, what is the sum? Go ahead and try and answer the A, B, and C, and then take a look at D and tell me what you get there. Go ahead and pause the video here and do that. All right, so for A, hopefully you got that A diverges. A is a diverge because the R value is greater than 1. B, it converges. And the R value there, the sum there was 1/4. With C, it also converges. And right there, the sum is 2. Will an infinite geometric series either converge or diverge, and explain? So yes, it will. If r is less than 1, it converges. If r is greater than 1 or equal to 1, it diverges. Simple as that. So yes, if r, the absolute value of r, if it's less than 1, it's a converge. If r is greater than or equal to 1, it's a diverge. All right, that's it, guys. Brief stuff, pretty simple. That's it. I'll see you next time. Bye.